Here's another variation on the problems with finding a common denominator for rational expressions. In this example, we can see that the two denominators are different, x plus 5 and x minus 5, and so a common denominator here, so common denominator is going to be using the product x plus 5 times x minus 5. So in order to do that, or in order to make that happen, I need to multiply the first fraction by x minus 5 on the top and bottom, and I need to multiply the second fraction by x plus 5 on the top and bottom. Now notice that when new stuff shows up in my denominators, I'm starting to use parentheses. Remember, the idea that I said before was that in a fraction like this, we don't put parentheses on the numerator or denominator, only because the fraction bar actually does that for us. This fraction bar implicitly means that the entire numerator starts at the 6x and ends at the 3, and the denominator ends in x minus 5. As soon as I need to put more stuff up there, if I want that numerator to be bound together, I need to use parentheses, and the same with the denominator. Okay, so now these two fractions have the same denominator, x plus 5 times x minus 5, but I need to combine the numerators, and so I have a lot more work to do in this one than I did in the previous problem because I have to simplify those numerators first. So the first numerator, this is just multiplying the x through the subtraction here. So that will give me x squared minus 5x. It's not so bad, and my denominator is still x plus 5 times x minus 5. The second fraction, I have the product of what we call two binomials. The binomial just means that there's two terms in each one of these, so there's two terms there, two terms there. So when you multiply binomials, we use FOIL. So that's first times first, outer, so 6x and 5, inner is these two multiplied together, and then the last ones. So if I do that, the first terms together is 6x squared. I don't have a lot of room here, so I'm going to do the outer and the inner and go ahead and add those together because those always can be combined. The outer, 6x times 5, is 30x. The inner, minus 3 times x, is minus 3x. So 30x minus 3x is positive 27x. And then finally, the last times last, the minus 3 times the 5 is minus 15. And the denominator is, again, x plus 5 times x minus 5. And so now I can combine like terms in the numerator. I have x squared plus 6x squared, so this x squared, 6x squared, is 7x squared. I have 27x minus 5x, so that's 22x. And then I have minus 15. And my denominator is x plus 5 times x minus 5. The only possibility for simplifying that further would be if the numerator factored in a way that canceled out one of the terms in the denominator. It definitely doesn't happen here. I think you can, if you're not sure about factoring it, you could use the quadratic formula to see that the numerator doesn't factor. But the roots of this are going to be something ugly. But anyway, I mean, the thing to do, of course, is just to try entering that into the box and seeing if that's okay. In this case, because I can see the numerator really can't simplify further, it's not going to factor in a way that cancels out. I know for sure that's the only, I mean, that's as simple as I can make that.